We're going to do differential equations with logarithms and exponents. So for the first one, we have dy dx is equal to cosine of x times e y plus sine of x. Alright, so for the differential equations, the first thing we got to do is split up our y's and our x's, but for this one in particular, we have an x and a y added together while they're raised to a power, so we can expand that. So we're going to have cosine of x, and since they're added, we can both set them up and multiply each of them with the same bases. And then from this point here, we need to split up our variables. Y is on the left side, x is on the right. So we should, after we divide this to the other side, we should have should be 1 over e to the y, which is the same thing as e to the negative y. Have our dy on this side is equal to cosine of x. Bring it down this e to the sine of x, dx. Alright, so now we can take the integral. This is the same thing as a negative 1, so we multiply that by the outside, so we have negative e to the negative y. Dy goes away because we just took the integral. Now take the integral this side. Alright, so this one's going to be a little different. We're going to have to use substitution on this one. The u is going to be whatever we raised e to the power of. So sine x, which means du becomes cosine x dx. Now we don't have to move anything around because we both have both parts right here. So we're going to be left with the integral of e to the u du on this side. Integral of e to the u is going to be kind of similar to the left side, so we're going to keep it as negative e to the negative y is equal to e to the u plus c. Alright, so now that we have both sides set up, we got to plug in what we have for u. So we should have something like this. Plus c. Now we got to get rid of the e's here because we're trying to get y by itself. We multiply by negative ln because we have the negative out in front here. So these cancel out, and this e cancels out, but this side becomes negative. So we have negative y minus sine x plus c. Get the negative to the other side, we have y is equal to sine x plus c. Alright, so for this problem, it's going to be a little bit easier than the last one. So we have dy dx is equal to 5 minus 2x y plus 1. Alright, so we need to get our y's on one side, x is on the other, so we should have y plus 1 dy equals 5 minus 2x dx. Now we're going to take the integral of both sides, and the left side is the same thing as our ln property, so the u is going to be y plus 1, which means du is equal to dy. So after we kind of plug everything in, we should have 1 over u, and the dy becomes du. Integral of this side is simple reverse power terms. So you're going to add a variable here. This one is raised to the power 1, so you're going to add 1. 1 plus 1 is 2, and then you're going to divide everything by 2, so you should have negative x squared, and the dx goes away and becomes a plus c. Back to the left side, we take the integral of this, we should just have ln of u. Make sure you add this in absolute values, equal to 5x minus x squared plus c. Now at this point here, we got to get u by itself, so we're going to multiply both sides by e. So we should have u is equal to e to the 5x minus x squared. And the funny thing with these problems is the c, once you raise it to a power, becomes the coefficient. Now we can just plug in what we have for u. So we should have y plus 1 is equal to c e raised to the power 5x minus x squared. Now all we have to do is get y by itself, subtract 1 to the other side. You should have everything like it is above minus 1. And that is your answer.